ladies and gentlemen.
So let's talk data interpretation. For math class or standardized tests, you need to be able to look at a chart, a table, graph, scatter plot, histogram, be able to look at data no matter how it's represented and be able to make interpretations based off of that data. So let's try out some problems because that's really the only way to practice and see how we do. So question 1, we have a scatter plot below, and it summarizes the reading abilities for a group of elementary school students based off of their ages. According to the graph, which of the following is true? So for a lot of these questions, you're not going to be making your own interpretations of data. You'll be asked which interpretation is true, which interpretation is false, kind of thing. So we have the age in years on the x-axis, and we have the ability level on the y. So as we can see a positive trend here. We can see clearly that the ability level goes up as the age goes up. So which of these kind of mimics that? So as the reading ability increases, as the age decreases, that is not true. As we get younger, the ability goes down. The reading ability is similar for all age groups. Well, we can clearly see that the older kids are doing better than the younger kids, so that's not true. The reading ability declines from 6 to 7. Well, I see a positive correlation there, not a negative one. And finally, the reading ability increases as the age increases. So for some of these, it's good to go and eliminate possibilities. So we know that some of these things aren't true, so we don't have to worry about them, and we're left with something that is true. So use some of your test-taking strategies to help out with these kinds of problems. Question 2, we're given a chart instead. So students in Mr. Whaley's calculus class took a poll regarding grades and study habits. Based off of the data in the table below, which is the best estimate for the number of hours studied with an 82 average? So if we look here, we see the average grade and the number of hours studied. So we're looking for 82. We're looking for something in between 80 and 85. And we can see that it looks like it just increases as we go up here. So we need an answer that is between 3 and 1.5. It doesn't make sense for a kid who got an 82 to study the amount of someone who got an 80. In this case, right? It doesn't make sense that they studied more than an 85, and that's just even more than that. So 2 is the only one that really makes sense there. Since we're looking at an average between 80 and 85, we should be looking for hours between 1.5 and 3. Last but not least, we have question 3, which is based off of this graph. Which of the following conclusions is true? So we have dollars here, and we have years here. The price doubled from 1990 to 2000. 1990 was 3, 2000 is 5. That is not double. The price in 1990 is half the price of 2005. We have 6.5 here. We have 3. That is not half. Then we have the price increase was less from 1995 to 2000 than it was from 2000 to 2005. So 1990 to 2000 was an increase of 50 cents, and from 2000 to 2005 was an increase of $1.50. So that is definitely true. We can see that in the slopes. It is a steeper slope from 2000 to 2005, so there's more increase there. And the last one, the price increased the same rate every year. We can see that this and this are the same. The slope is the same, but this slope is less, so that would be false. So a lot of these is just using your test-taking strategies, process of elimination, and, your reasoning skills. So if you have any questions about anything, let me know. Otherwise, I'll see you in the next video.